So, hello everyone. I'm assuming I'm being heard.
Yes.
Good, good. All right, so I'm glad to be doing this. I was scheduled to come to an HITB in the spring and was forced to cancel from pandemic. So here's looking forward to a vaccine when we can all sort of be in the same place at the same time again. Um, in this talk, let me switch my screen. I want to tell you all what's going on with DNS encryption. DNS is an incredibly important protocol. It's used for everything, and that means everybody wants a piece of it. And that has had an interesting impact. We've spent a couple of decades at this now, and there are now bodies buried everywhere. I gave a shorter version of this talk about 15 hours ago at another virtual conference. That was the first conference in virtual Montreal, but it was about half the time slot, and so I had to remove a lot of material. So you guys are getting the full delivery, and I guess we'll just launch right in. So many of you are DNS experts that you're going to be bored by a few of my slides. Please bear with me. The DNS system architecture was settled in mid-1980s and hasn't really changed much, right? We've changed an awful lot around the edges, but the protocol has got a lot more options to it. But ultimately, the system architecture is the same now as it was then. And that is shown on this slide. We have answers coming in at the top through the authority servers. That's usually a zone file, which is a text file that you would edit with a Emacs or Vim or something. But it could be a database, it could be software. Let's say you're running a content delivery network. Your authority server is going to be making programmatic decisions about how to answer questions. DNS doesn't really know where the data comes from. It just has a role for that server, which is to be where the answers come from. At the bottom, we have stub resolvers. These are in your smartphones, they're your laptops, every virtual server, every physical server, most routers, switches, anything that might need to make a DNS query, which is pretty much everything, has in it a stub resolver. And that stub resolver knows very little other than how to contact a recursive server, which I'll talk about in a moment. But at a truly high level, the answers are coming in at the top, the questions are coming in from the bottom, and they are meeting in the middle. And that is the system architecture of DNS. Now that recursive server in the middle, the full resolver, is where all of the complexity, most of the bugs, and sort of a huge amount of the innovative business opportunities all occur. It's also where DNSSEC is done. So it's where answers are validated to see if they have signatures that match their keys. But we're not going to talk about DNSSEC today. That happens to be another kind of crypto that also gets into this, but it's not about secrecy. And we're talking about encryption as in secrecy today. So before I leave this slide, I want to make sure everybody knows two things. First, that cache over on the left is vital. This system was designed when there were about 1,000 universities and government contractors connected to the ARPANET, and it has grown 8 to 9 orders of magnitude since then without any basic redesign. And that's because of that cache that has been able to occur. So if you meet Paul Makapetris, who invented all of this, you owe him a beer. Although he doesn't drink beer, you owe him fine red wine. Anyway, the other thing you need to know is that the conversation between the stub resolver and the recursive server is extremely important for privacy. That is personally identifiable information under any government legislation around the world that you care to point at. They're going to say that if the IP address, which identifies a device which is held in the hands of some user, if that IP address is connected to a stream of statements of intent, which is what your domain name lookups are, these are the domains I want to visit, that's PII. And so in a sane world, you would really want to keep that close at hand. You would want to keep the recursive name server nearby. Keep it on your own LAN, maybe on your own server back when servers were big. But you certainly wouldn't sort of point to a recursive server that was outside of your jurisdiction, did not share a legal regime with you. You didn't have a contract with them, and you had no idea who the middlemen were that would then be able to data mine those transactions, because that would be crazy, except actually that's what we do. And it is crazy. In the original design, as it was practiced back when computers were large, servers were expensive, and a company might have one of them, there tended to be a firewall between the local server and the rest of the ARPANET or internet or whatever it was by that time. And that firewall would have a simple rule that said, if you want to speak DNS, then you had better be that recursive server, because if you're trying to speak DNS and you are not that server, I am not going to let it happen. That will be stopped at the firewall. And that, in other words, dare I say, encourages all of the stub resolvers to actually use the recursive server that is inside the firewall, because if they don't, they're not going to be able to look up any names. So this worked. It got us here. It's not really how things work today, but it did work. And we should give it a longing look before we see what's happened. This is the system topology, not so much the architecture of the internet, but just how we all were connecting to it when commercialization and privatization first really took off by around Y2K. And so you see that your users and applications, which might be on a workstation or a PC or whatever, we didn't have smartphones yet, that's where questions were coming in, that's where applications were being run, that's where the internet was being accessed, and it was connected to a local area network, which could be an Ethernet, thick wire. It was a great thing. You used a pocket knife to connect to it. Or it could have been Wi-Fi. There was Wi-Fi, early versions of it back then. But one way or another, you had to connect to something that was then connected through the campus, which might be a building, or might be several buildings, or might be a floor of a building. And that would then get connectivity from an internet service provider, or maybe more than one, which have the job of then connecting all of this stuff behind it to the internet. And again, this worked. It's not how things work today, but it is how it was all done back when it was first taking off. It's a lot more complicated now. Why is that? Well, because there was money to be made. There were gold in them there hills, and a lot of people said, hey, this internet thing is my ticket to riches. And they looked at something they might be able to do, maybe creating an app, maybe starting an ISP, maybe, hey, what's this web thing? What's that going to be? Maybe I can get in on that in the early days. Whatever it was, there was a lot of ambition, a lot of really creative people. And again, a lot of money to be made, a lot of venture capital, a lot of people were, making their life, they were making their retirement at a young age based on stock options. And that's magic. That's like a drug. You want more. So some things happened, and they happened in DNS. I'm not going to talk about what didn't happen in DNS. There are history books for that. Right around Y2K, VeriSign, who was responsible for .com, decided that they really wanted to make more money than they could get by selling names in .com. And they realized that since most names on the internet were in .com, that they were in a perfect position to data mine what everybody was actually interested in, and even sell them ads or deliver ads that somebody else would pay for. So they partnered up with this company called SiteFinder, and they put a wildcard into the top of .com. Now, a wildcard is not a protocol violation, and VeriSign made that point at the time, but it was kind of a norms violation. And I realize today, 2020, when norms are laughable, but at the time, we had norms, and if you violated one, people would look at you funny. And what this really meant is you couldn't get a negative answer. If you asked for whatever, some random string of characters .com, you would still get an answer. You would get an address, and that address would be of a VeriSign SiteFinder website that would give you an ad. and they would find somebody who wanted to buy that ad impression. So this is sort of early surveillance capitalism. I guess at that time, as an example, just to contextualize this for you, Google did not yet know how it would be profitable. They were running a search engine. It was very popular, but they weren't quite the steamroller they are today. So these were early days. This was an experiment. It failed. And when I say failed, I mean that a lot of people sued them. They sued ICANN. I got named as a co-conspirator in that lawsuit because I helped to stop it with a bind patch. So yeah, good times. Eventually, the lawsuits were all settled. Everything went away, and we waited a couple of years until OpenDNS came along and said, you know, what VeriSign did with those ads, that was wrong. They shouldn't have put that wild card there. What they should have done is to put a recursive name server out on the internet for everybody to use, and then encourage people to not use their ISP name servers, not run their own, but instead to crawl across the entire fabric of the internet backbone to an OpenDNS Anycast instance and send their questions to us, because then we, OpenDNS, can associate that IP address with that domain name as if it was a search string and help target ads toward those people. In fact, they delivered ads. They intercepted the negative answers that would otherwise have come if some user looked up something didn't exist, and they replaced it with a positive answer that had the address of a web server that gave an ad. You've heard this story, right? This was not a big deal until they decided to redirect www.google.com, at which point Google said, we wish you wouldn't do that. And OpenDNS said, well, it's not really against the law. And we are, after all, sending all of the people to you after we, show them our search page and gather their search string. You still get all the traffic. We just get to see it, that's all. So Google didn't love this plan, and 8.8 was launched shortly thereafter, possibly in answer to it, although Google's not talking. And that was the new state of affairs for a couple more years, until somebody came along and said, I have a CDN. I'm in the job of, I'm being paid to deliver people to the closest web server that can answer their questions. So if you're going to www.microsoft.com, you're not talking to Microsoft at that stage, you're talking to Akamai. And Akamai has the job of trying to figure out where you are. And then they've got hundreds of copies of the Microsoft web service around the world, and they can direct you to the one that is close to you, nearby. And that saves a huge amount of overhead, makes everything faster, probably makes it cheaper. So it is kind of the way all mature content is delivered today. But the problem is they were using the DNS request as a hint of where you were. In other words, when they were trying to figure out which web server to point you at, they would look at your DNS question, they'd look at your source address and say, well, that source address is, it's in Malaysia. I'm going to give them the Malaysian version of the Microsoft content. And, I'm sure you see where this is going. If you're using OpenDNS, the source IP address of your DNS question is no longer yours, isn't from your school, your enterprise, your home, your ISP. It is OpenDNS's. And of course, OpenDNS knows where you are, but they didn't have a way of telling Akamai where you are when they were asking Akamai, gee, can you help fulfill this request? And so they invented a whole protocol called ECS, eDNS Client Subnet. And I am the creator of eDNS, so you can blame me for the fact that this was possible, but not for this. I fought hard to keep this from happening because it's a layering violation and it makes a lot of things more complicated, as we'll get to. So the idea here is when OpenDNS is passing on your query to Akamai, they include your IP address as kind of additional data in that query. By the way, this is where the user is. So if you're going to give me a crafted response, craft it for that address. And they did what they could to avoid having this be a privacy problem. You're not supposed to send the entire IP address, just whatever the Class C network or something like that. Sadly, a lot of recursive server operators didn't read that part of the spec. So I I help operate one of the root name servers. I can tell you we get a lot of full IP addresses in eDNS client subnet. So it's a bit of a privacy problem, but that's not why we're talking. Why we're talking is that this complicated everything, and it started. Not only are we sending everybody's data all over the internet before it finally comes back as a useful answer, we're having conversations between two different uncontracted parties who are now touching your PII. And of course, none of it was encrypted. And so when Edward Snowden flew to Hong Kong a couple of years later and told the world how governments behave, which I guess some people already knew, but it was a shock to some folks. So it was a sort of a big press-worthy event. This is part of what he said, is this type of internet metadata is being used by surveillance, the surveillance empire, the CIA, the NSA, whatever, fill in the blank, alphabet soup of your choosing. And a year later, the Internet Activities Board, who is sort of part of the Internet Engineering Task Force, IETF, published an RFC. That's normally where protocols come from, but this was not a protocol. This was guidance. And what it said is, all the stuff Edward Snowden said, that's bad. And you need to change, all of you in the Internet Engineering Task Force, you need to change everything so that none of that works anymore. So I can draw a straight line through these 5 data points. I can tell you that the reason that they had to do this was because of these earlier steps that had been taken. If DNS still worked the way it had pre-commercialization privatization, pre-SiteFinder, pre-OpenDNS, pre-eDNS client subnet, then Edward Snowden probably would have had a lot to complain about, but DNS would not have been among it, because we wouldn't have been flinging all of this unencrypted data all over the place the way we now do for business reasons. So I'm sure you can imagine that a lot of times you don't make a plan to get to a place, but you end up in that place and wish you had had a plan so that you weren't there now. Anyway, this is the topology I'm describing. So you've still got the users and apps, still got a LAN, still have a campus and an ISP. That hasn't changed, but you're now reaching all the way through the internet to reach your recursive DNS. And then they are sending your metadata, your PII essentially, off to the CDN. So there's a huge opportunity for middlemen, both government-sponsored and just normal surveillance capitalism and just ISPs trying to make a nickel, whatever it is. Everybody got in on the game. So there was a backlash, as I said. There was an RFC, said, hey, you got to encrypt all this stuff. And so the DNS team got together and said, all right, well, how do we encrypt DNS? I don't know. Let's not invent anything. Let's use TLS. That's working for HTTPS. It'll probably work for this. And so they did, and it works. And it's not widely deployed for reasons I'll describe, but it does work. But it is a TCP protocol, just as the web at that time was a TCP protocol. It had a different port number, TCP port 853 instead of TCP port 53, but it was so much better than the protocol. Even if you weren't going to use encryption, you would still want DOT for a lot of other reasons. It was really, really cool. Just well done stuff. I was not on that team, so I'm just, I wished I wore a hat so I could take it off. And the interesting fact about all this is that network operators can still forbid this traffic. You can still have the firewall I showed you earlier, and you can just say, hey, look, if that's the port number, you're not getting through. But what you can't do is see it. It's not transparent to you. You cannot data mine it, and you can't modify it, because if you do, then you'll be violating the crypto wrappers, and everybody will know you did it. And this was, it was good engineering. They solved the minimum sized problem and added as little complexity as possible. And they said, okay, we're done. The web community said, well, you may be done, but the problem isn't solved, because we hate this fact that the network operators can forbid it. We do not want network operators to be able to forbid it, because if that's possible, then some authoritarian country somewhere with a single party political system might just say, well, we don't want you to use protocols that we can't surveil or intercept, therefore we're going to block it and force you to use some other protocol that we can. All right, so this is a form of pre-negotiation. You're just trying to avoid the whole conversation about whether that surveillance can be compelled, because you can't tell that it's even happening. And so they put it on top of HTTPS. So it looks just like e-commerce, and most people are not real comfortable saying that they will turn off e-commerce because their economy might suffer or even crater. And one of the creators of this protocol went so far as to say, yeah, we're putting this on TCP port 443 along with the web so that a network operator may, quote, and I quote, think twice before blocking it, unquote. So they're casting kind of a wide net. They're saying that all network operators are suspicious, including me, for reasons I'll get to in a moment. So yeah, if you're doing parental controls, it was probably DNS. If you have a company policy about either observing what the employees do and observing what the company servers do, it was probably DNS. If you even had some policy that maybe malware was not going to be able to look up its command and control names or something like that, that was probably DNS. So DOH disintermediates all of that and sets us back to square one in terms of securing everything else, because we had gotten used to using DNS as a way to find out what was going on and put a stop to some of it. And I say we, I'm not in the surveillance capitalism business. I have a company network and we use DNS to secure the assets on that network. You might be in a similar situation, in which case read on. So after 2014, when they published that first RFC, took about 2 years, and then we got DOT, and then it took about 2 more years, and then we got DOH, DNS over HTTPS, which is just as non-transparent and just as imperturbable as DOT, but is also not detectable and therefore not blockable. So that's the only real difference there, besides complexity. And then recently, this year, the IAB said, it's been a while since we spoke on this topic, and they wrote RFC 8890, which says that the internet is for end users, justifying pretty much everything I just said. It's not justifiable, right? I am an end user, but I don't have a Wi-Fi chip in my brain. I have to use a laptop. That laptop has software, some of which I have some source code to, some I don't. So if you're going to say the internet is for end users, what you mean is the internet is for apps and devices and IoTs and things that end users can see and touch. And it turns out that that software, those devices, their interests are not aligned with the humans that are using them. I know this comes as a big shock to the IAB, but in the security industry, we're familiar with this problem. Okay, so here's how it turned out. This is the current situation. My team created the stuff over there on the right, which is a standard protocol called DNS TAP for monitoring what your recursive server, or indeed any server, is doing, so that you can, I don't know, use it to make behavioral analytics about what your computers are doing, what your servers are doing, what your customers, employees, etc. But we also developed something called RPZ, which is a firewall system, standard protocol interface for telling that recursive server that it should lie about some things. For example, you might have a rule that says if it's one of today's 50,000 different configure C command and control names, block it. Yes, we'll have some false positives, but at least we'll make sure that if we have any configure clients in our network, they won't be able to find out who their command and control is. So, that's lame, but it's the best we can do. So the stuff on the right, yeah, we did that. Stuff on the left, that's the new thing. That's applications doing DNS, ADD. I'm going to introduce you to a working group about that, so you can go join them and tell them what you think they should do differently. But the idea of an app doing DNS is principally it's a browser, and the browser is going to speak DOH to a recursive server that your firewall doesn't see and cannot stop, which means that whatever behavioral analytics or policy you were doing is now irrelevant. And that's your new situation. That's where we've gotten to in 30-odd years. So let me explain a little bit about how this happened. The internet and the web are different things. The internet was a network of networks because we had networks first, and then we had an internet to connect those networks together. And it was understood that every one of those networks was autonomous. And it had policies, and it had edges, and it had borders. And the web is not any of those things. The web is a network of eyeballs. It is all about figuring out what people are doing so that you can predict what they'll do next and control their choices. It's an economic device, not a technical device. And although it has a lot of technology in it. So we're going to have to do some things to TCP port 443, this HTTPS protocol, because you're not going to have this man-in-the-middle firewall anymore. TLS version 1.3 with the ECH option means that you don't have enough information in the headers to decide whether to get in the way of an HTTPS flow anymore. So if you've got a next-gen firewall and it's doing a good job enforcing your policy, you might want to talk to whoever sold it to you and ask what they plan to do about TLS 1.3 and ECH, because none of that's going to work anymore. And if you want that, you're going to have to make a proxy and require every device on your network to use that proxy so that that proxy can strip search every data as it goes through your gateway and decide whether it's good or bad. This is where you take what used to be a lame solution and you make it impossible, so you then get a worse one. It is bad planning at scale. Also, because DOH is a bypass to a lot of things that network operators do need to do, I expect that there will be catalogs of DOH servers, some for people who want to bypass censorship, others for people who want to block them all so that they don't accidentally end up letting their IoT devices or their edge devices or their users, customers, family members talk to those things. So there's a lot of bad stuff coming. And it is because the web grew up in the internet and has now outgrown the internet and wants to go its own way. And it's a totally different system of governance. And let me talk about that. Larry Lessig wrote in Y2K that code was law, and you should read that. It's an excellent essay still. It's as true today as the day it was written. And what he really meant is, yeah, the laws of human society don't apply if they can't be enforced. And so the people who write the code are going to have more power to determine human destiny than the people who write the laws. And he was right. But I got to say that right now, information superiority, in other words, the code that is the law, is vesting in corporate open source publishers, much more so than it is people like me back from my days of doing cron, or people like Daniel with curl. You know, there are some really great people who are still writing really great software, but most of it is coming from big companies. And if you want to understand what that means, in 1990, being an open system meant that you could understand it or even change it. But in 2020, the same word means something totally else. It means just that it could be forked. So think of Android, right? They call themselves an open source system, but if I've got an Android phone, chances are if I don't like the way it works, I can't do a damn thing about it unless I first root it. And you know, that's not what open systems used to mean. So the openness of all this has become a tool of the man, in other words. So in the internet era, we had all these different parties from between this side and that side, and every one of them had to agree that they were going to participate. All they had to do is slide their little gate up or down for certain types of traffic, like spam, let's say, and all of a sudden that wouldn't work because they would say, I'm not doing it. And that meant that your alignment was negotiable. You could withdraw it if you did not, if you just didn't feel the feels about that traffic, you could say no. So we don't have that world anymore. And to introduce that, I want to help those of you who forget sometimes which way the direction of entropy points. More means kind of like more random. So The entropic heat death of the universe is predicted as when there's nothing in the universe that is hotter or colder than anything else, or closer or further from like kind than anything else. If you have raised children, you know that toddlers can do this with objects in your house, so that there will be absolutely no pattern. Everything of like kind will be equidistant from everything else of like kind by the time your toddler is done remodeling for you. So in our world, we know entropy because encryption and compression are both seeking perfect entropy. That's where there is no pattern remaining, which could be compressed further, or which could be used to, say, uncompress, or excuse me, decrypt that which has been encrypted without necessarily having the key. So perfect entropy means there's no pattern remaining, no discernible pattern. There probably is one, it's just not discernible. And if you don't get it perfect, that will be the attack surface. In particular, if you're trying to, let's say, encrypt your traffic so that it can't be detected or blocked, then anything you don't encrypt, anything that has a pattern left to it, is something that maybe some system administrator somewhere is going to grab hold of and say, aha, I can get a handle on this after all. So what you really want to do is make sure that you have perfect entropy, at which point you get the ideal web state of affairs, which is that there is no negotiation. Your alignment is forced because no one in the middle can tell what they're carrying. They can't, not only can they not see it, they can't perturb it, they can't even identify it well enough to decide whether perhaps it's spam that they don't want to carry. Sorry, that choice has been taken out of your hands because apparently Edward Snowden flew to Hong Kong. So that's kind of where we're headed. Now, let me explain how this relates to encrypted DNS. DOT is available. It's in a number of different open source servers. You should turn it on, but you just got to be aware that it doesn't work all that well yet. There are plenty of TLS libraries that are used on the client side who don't know what to do with an IP address in the server alt name or the common name, which means that when you negotiate TLS with them, you send them your certificate, they compare that to the IP address that they started with, because they didn't have a domain name for you. All they had was your IP address, and they don't. The comparison sometimes works and sometimes doesn't. So DOT is having a tough start because the idea of an X509 certificate for an IP address is somewhat new, and it's just not well supported yet. It's in this protocol, it's just not in all the libraries people use yet. Nevertheless, Android can use DOT. If you turn on DNS privacy on an Android phone, that's what you're getting. And it works. I've tried it. It's fine. But because it's blockable, because it can be firewalled, because it does not have perfect entropy, it's not really growing at the moment. I think we're going to see a lot of that between the recursives and the authorities. We're not going to see a lot of DOT down at the end user where the stub resolvers and the smartphones are. That's where DOH is really taking off in a big way. So Mozilla for Firefox decided to do something I find controversial, which is that they will turn on DOH. They will select one of their own trusted recursive resolvers, ignoring whatever your operating system's using, whatever you've got in your settings is all gone. They just choose one of theirs. And then they put up a pop-up offering to change it back to the unsecure way that it was before, if you really want that. Yeah, I don't love this. And I've had some arguments with them about that. And I've deleted all the Mozilla Corporation software in my house and among my family and so forth. And I don't know what to do about this level of corporate activism. Chrome took a different approach. They said, you know, we'll upgrade to DOH, but we're not going to change what server we talk to. We're going to try and use DOH to the server you have selected. And if it works, we're going to use it, because we assume that if you chose that server, you don't care if we encrypt the traffic to it. And that's a reasonable assumption. I think the other Chromium forks, I use Brave, are going to do the same thing, but they're waiting for this working group about apps doing DNS to complete its, I guess, deliberations before they decide what they're doing. Windows next year will start doing what Chrome does. They're going to start using DOH if the server supports it, but they're not going to change what server you're using. It's unusually polite of Microsoft to say, yeah, we respect your choices. Apple made a similar choice, iOS 14 and macOS 11 that are already out there, can use DOH right now. It's a system-wide config that you can decide whether you want to use, or, and this is the part I didn't love, any app can decide to turn it on. So if you've got an app that does not want to be subject to your DNS controls or your IT department's DNS controls, then they'll just call the right API for that, and they'll be using DOH. And you did not get a choice about making that impossible. MDM can do that. So to the extent that these are non-malicious apps, non-malicious devices, they're not poisoned supply chains, they're not intruders, they're just well-behaved devices that actually care what the sysadmin thinks, then MDM will stop them from using DOH. But who cares? That's not our use case at this conference. So there are a lot of end users that are very happy about all of this. And they think that DOH as an anti-censorship system is really good because they want to do things that the people upstream of them don't want done. Whereas the family and corporate network operators are unhappy for the exact same reason. So transparency very much in the eye of the beholder. Notably, in the last year or so, Comcast sued Google about DOH. They said it was an antitrust problem because, and this is Comcast's words, not mine, they said both companies are in the advertising business and they compete and they both need end user data. They both have to data mine that data stream in order to succeed as advertisers. I thought, wait, Comcast, I don't pay you to advertise. You're my ISP. And you know, this lawsuit evaporated at some point, but it was a very interesting shot across the bow for them to admit, yeah, we all just want to data mine stuff, and we hate Google because they're stopping us. Ooh, okay, so Russia said, yeah, we don't think this is good for our economy or for our one-party political system. And so when we see TLS 1.3 or encrypted SNI, DNS over HTTPS or DNS over TLS in our national gateways, we're going to block it. Now they didn't mean ESNI, that's been renamed to ECH, but you know the intent was clear. But I have to say they will not be alone. There are a lot of countries that are going to take the same view, and maybe that's because it's the only way one-party rule can survive, or maybe they've got other concerns. Maybe they're actually, I don't know, trying to stop crime. Maybe they're wrong, maybe they're right, but it used to be that they had the sort of national sovereignty to make this decision, and now they don't. The IETF makes it for them, and they are about to say, well, IETF, let me explain things to you. I recently, I think 2 days ago, heard that macOS Big Sur now bypasses Little Snitch for a lot of Apple applications like FaceTime. Apple, in spite of their 1984 Super Bowl commercial, apparently does not trust its users to know how Apple's products are communicating with Apple's mothership. I guess I'm glad that I learned that when I did, because I loved this new M1 thing they did. I was going to buy a laptop, but not now. It's hard to believe Windows is more open and more respectful of my choices than Mac OS, but this is the brave new world. So this is getting worse. And I just want to let everybody know, if you're in the AV business, you got trouble, because we're moving HTTP itself over to UDP on an unconnected socket, which means there will be no kernel event by which your AV hook can say, I wonder if I will approve or deny this particular attempt to fetch content. You also won't be able to see the content. Only the innards of the browser will have the necessary decryption logic. So your ad blockers, going away. Content filters, going away. Those will exist inside the browser. They will no longer be in the operating system, and they will no longer be add-ons that you get to sell that are adjacent to the browser. The browser is the new platform. I think I mentioned the web is a totally different economy than the internet was. So what can you do? Well, I recommend that you just embrace the inevitable and say, you know, I lost the war. We lost the war. We cannot do what we used to do. We cannot, you know, I'll probably get away with it for some uses. I'm going to make a proxy somewhere, and I'm going to require everybody behind the firewall to use that proxy if they want to speak HTTPS off network. But I think you can imagine that there will be a lot of screaming. And most of you probably can't get away with that. And I myself am eventually going to have to give up on it in some form, which form is yet to be determined. So don't do that. I mean, good luck, but don't do that. Don't try that. What I recommend you do instead is look at Mozilla's rules. Mozilla Corporation established some rules for their trusted recursive resolvers, and I don't like what they did. I don't like the fact they're ramming DOH down my throat and then saying I could opt out if I want to go back to the old insecure way of doing things. That's bad practice. Nevertheless, they publish some rules. The rules are useful, apart from the purpose they were convened for. And it is limit the data. Don't use it for anything except answering queries or diagnostics about those queries. That's always been Google's policy for 8888. Seems to be working. Be transparent. In other words, let everybody know exactly what you're doing. Don't make secret sort of data mining use of this stuff and not tell anybody. Don't do anything that you're not willing to admit to. And then finally, don't filter. They really hate content filtering over there at Mozilla. So they're just saying, unless the law requires it for that user, don't filter anything. Okay, so I'm going to filter stuff, right? I helped invent a DNS firewalling protocol. I'm going to filter stuff, but that's me. That's at my company. That's not you for your ISPs or whatever your large customer base is. That's just me with my employees. I can get away with anything. But look at those rules, and you should just embrace those rules. You should say, I'm going to operate my recursive server according to TRR rules. And I know you're not going to love it. There's some things you're going to want to do that you can't. But unless you're doing it for your own company or your own house, you can't. So do this and just realize that no matter how much you hate it, the alternative was worse, which is that the traffic simply moves away from your server, and then you don't have any choices left at all. So that is worse. So your arm's being twisted. You should resent that, but your arm's being twisted. You got to go where they're telling you. So deploy DOT in all of your servers, deploy DOH in all of your servers, and encourage all of your users to turn it on. This is known as the Comcast approach. They couldn't beat them, so they joined them. So they are actually applying to become a Mozilla TRR for the universe because they are now running a correct, TRR compatible server. You need to do the same because your users are going to be turning on DOT and DOH. You want to give them a choice that is not also to move that traffic away from your server. And I want to say, having recursive DNS be local is always better. And you should use a Pi-hole, or you should get a Raspberry Pi and install Linux and Unbound on it, or whatever is your technical level, you should do that. Because if you can keep that traffic local, then yeah, you should probably still encrypt it, but you don't have to worry about downtime from other people's servers, other people's networks. You don't have to worry about maybe they are under some government order to decrypt the data and hand it to somebody because you don't know what regime of laws they're under. So yeah, you should definitely do what you can to keep your traffic local, and that means turn on DOH and DOT and run your server according to Mozilla's rules. That is what you have to do. It could be worse than that, but that is the minimum cost of living in the era that you have been dragged into. So let me remind everybody that in any given era of human history, there has been a dominant operational mode. And that remains dominant until it's eclipsed. So if you had total superiority on land, that mattered until somebody got superiority at sea and came at you from a direction you couldn't defend. And when you had land and sea and somebody came at you through the air, again, didn't matter. Your dominance had been obsoleted overnight because somebody could drop whatever dynamite on you from biplanes or whatever that was. Space did the same. Information, that's where we are now. We're in the information age, and each of these has obsoleted whatever forms of dominance came before. We're in the information age, and information supremacy matters. And if you can't get supremacy, you want at least parity so that you can hold your own against somebody who's very strong in information or space or whatever it is. And if you can't get parity, you at least want to know what they can do to you. But we're headed for quantum. But right now we're having about a 50-year stopover in information, where being able to surveil and predict and control is the key to success for both governments and corporations and wealthy individuals. It is your dominance in information that will control your destiny. I also want to point out, and I think some of you have seen this slide before, complexity is bad for risk. The more you have, the more things you have that you don't understand, or the more things you add that you don't also add understanding about, the less safe you will be. The more risk you will have that you can't understand and therefore cannot manage. And so as we sort of keep turning the knob and saying, let's make everything more complicated, there is a whole other set of effects that we are embracing, however little we intend to. Here's the article I told you about with Russia, in case you thought I was making this up. I'm not. This is where we're headed. Most of us as people are really concerned about our next meal or making sure we have retirement savings or whatever, not as concerned about whether our grandchildren are going to be up to their necks in warm seawater because of climate change. And it's not because we don't care. It's not because we don't love our grandchildren or great-grandchildren. It's because we got other trouble, and we're kind of designed by evolution to worry about the problems that are closer to hand than those. And I want to say most real people are that way, but all corporate persons are that way. They all live within the current generation. And so getting here was actually inevitable because of what capabilities and what challenges existed at different times. But again, this loop, this while loop of surveil, predict, control, and then repeat ad nauseum, that is, for the companies or people who want to work less but have a better standard of living, more luxuries than other people, it's going to be because they do this better than other people. This is it. This is the key. And this is what's driving what I sometimes call the general crapification of everything, is that this is now the key. So configuration defaults are destiny. The internet protocols are destiny. You're going to get these devices, you're going to buy them, your family's going to buy them, your employees are going to bring them in as BYOD, and you're going to have to cope. What this means is that big tech employees today can have bigger regrets than ever before in history. They can build things in their 20s and 30s that they then regret the hell out of because they have to live with the societal impacts of that in their 40s and 50s, but it's too late. By the time you have that perspective, you can't go back and tell your younger self, hey, don't build that. You won't like what happens. No, that doesn't work. But here's what you can do. There's an ADD working group, and they are not security aware. They are a bunch of DNS people. And I am a DNS person who is also a security person. I created the first RBL, the first distributed reputation system. I care deeply about security. That's why I've been using DNS to secure other things. These people are not like that. They are DNS people, and they need to hear from you. They need you to join their mailing list, go to their meetings, and comment on their drafts and say, if you do it that way, all hell's going to break loose. Let me explain it to you. If you're counting on me to stay awake 22 hours a day and drink all the coffee in the universe and do that for you, I have to disappoint. There's also an encrypted DNS initiative at EDDI. So these two URLs are there. So that's it. We have a few minutes for questions. There is some stuff on the screen. Please reach out. I get a lot of email. None of it's from you. Change that. I'm on social networking. We've released some free stuff recently that, please take a look at. It's kind of cool. And then, of course, I have a day job that I have to mention. But that's it. So let's take some questions.
Right, so we do indeed have some questions. One is one that I was myself curious about. You mentioned in the eDNS uh, bit that they were supposed to only send the Class C network, but were in fact sending the full IP. I was wondering if that was any different for IPv6.
I thought it would be. I thought that the code base would just be more modern if it spoke v6 at all, but no, it tends to often be /128s as the mask. And I'm not talking about like 8.8. They do the right thing. Google follows the protocol. Cloudflare uh, does not trust eDNS client subnet at all and does not use it. So if you use 1.1, you're not getting eDNS client subnet. You're not getting any of that weird stuff that's designed to optimize the CDNs if you use 1.1. But 8.8 does the right thing, 9.9 does the right thing. It's just sort of the enterprise name servers of the world that get this wrong.
Okay, one more question. How likely is it that we will see a wormable DNS flaw issue again, aka secret, in something else, say Linux?
There is 100% likelihood. Um, and that is because we are entering the cargo cult phase of technology evolution, where, I don't mind that we've got programmers that don't know what a transistor is. We've got programmers who don't know what a 1 or a 0 is, what a bit is. And they are writing our future. And, the Linux team is really good, but it's also really big. And if you think about something like shell shock, it sat in the Git repository for a couple of years before anybody noticed it. So we can't say that openness is going to save our asses in the future. We have to say that inevitably everything is going to turn to, well, we're all going to be in warm muddy seawater up to our necks, both digitally and physically.
Okay, that is quite literally all we have time for. It is a minute to the hour. So, Paul, thank you ever so much for taking the time out to have a chat with us.
I
And
loved this. Thank you for inviting me. Please restore this to a physical thing so that I can come.
oh, we very much want to as well, I can assure you. Paul, thank you very much.